Welcome back everyone. Today we are going to talk about nearest neighbor classifiers. We as human beings know when we look at any object, but here we are talking about training machines and learning how they can identify various objects. So when they look at different images, they have to recognize what that image is of. So we have many examples in front of us, for example, pictures of ducks, cats and different animals. So how does our program identify which image is of which animal? So what it does is basically it tries to identify the specific features in every image, just as human beings do. So how they basically identify the features and how they can identify which feature belongs to which animal. So this is arbitrary how they work. So once you have a list of extracted features which are going to contribute in identifying the image, we can easily classify the image. For example, in this particular scenario, if we take two type of features, which is number of legs and number of wings, and we try to differentiate every single image in terms of these two features or attributes, let's see how it happens. So we can see, so any image which has an animal having 4 legs, you can see it lies on the graph on the vertical side, and any image where we have animal which has wings, then we actually place it and clutter it around where it should belong in the graph. And here you also see that images which are belonging to same type of features, they are circling around the same place, or they are making a cluster around each other. So any new image which your model will get, it can easily place it closer to the images which belong to the same features as the new image has. So that is why here we can see that the new image is placed to the nearest neighbors for the training matter. And formally, basically how it happens is all the features which are belonging to same category, they are residing on the same space, and all the images or all the data which belongs to those features, it start gathering around each other. And as you can see on the graph, all the red dots are gathered around each other. So they belong to some features which are similar, and then the white nodes, they are gathering around each other. So they have some specific features that they belong to, and they both, the red ones and the white ones, they totally have different type of features. So it basically requires 3 things: the set of stored records, points described by features as we are mapping it onto the graphs, the distance metric to compute distances between records, and the value of k. Let's see how that value of k works. So basically what we try to do is we use labels of every single feature, and we try to create neighbors around that to determine the class of that neighbor. For example, in the previous diagram you saw that we identified number of legs for animals, and we started placing the image on that specific area of the graph, and eventually we can then say that 4-leg animals are cluttered around that particular side of the graph. So we identified a new label for that, and that is done by majority voting, because all the images which among all the images, the feature which is common, feature which is seen on most of the images, wins by majority, and that becomes a label of that particular group or class. So how do we compute it? Theoretically, we just saw it, but mathematically we use the Euclidean distance formula to compute whether 2 different objects lie closer to each other or not, and that is determined by measuring the distance between them. That is a simple formula. We basically take a square root of the distances of both of their coordinates in the graph, and we identify their placing there. And we take the majority vote of class label among the k nearest neighbors. That is a standard case. As I said, we basically choose the one feature which has the majority among all the data set, and then that becomes the class of the label. And that is basically done with the vote according to distance, and the weighing factor is w is equals to 1/2 of the distance of the square. And here you can also see that how different colors are depicting different clusters or neighbors, as you see. So this is the Voronoi diagram for how different clusters are formed when our model is trying to train, and every color shows a different type of feature, a different type of cluster set which is in the training set. This is it for today. Thank you.